Now, timers are effectively a much more precise method of delaying the program. Like it's like running a timer in parallel whilst doing something else. Whilst our more simple variant of the delay was effectively just sitting in a program, wasting time until a certain amount of time has elapsed, then only then does it exit. This allows for a more parallel execution, and it's much more precise. So we're going to do this obviously with timers. And how do we do this with timers? Well, the datasheet tells us that if you go to the correct one, there are timer 2, 4, and 6, and timer 1, 3, and 5. So there are quite a few, and timer 0 as well. So we have effectively 7 timer units at our disposal. So we're going to effectively use timer 2, 4, and 6 for this example. But you could use 1, 3, and 5. But the 2, 4, and 6 are just a bit easier to use, in my opinion. So we're just going to use, okay, so first things first, we're going to set up, remember, the right value in the right register at the right time. So we're going to use timer 2, and we're going to access the T2 con register. So first we move the value that we want into the working register, then we move the working into the T2 con register. So timer 2 control register. So we go ahead to the datasheet, check what's going on here. And here, the timer X output post scaler select bits, the timer 2 on bit, and the timer 2 clock prescale select bits. So what is a post scaler and a prescaler? So what a timer does is every time a clock cycle occurs, it counts one forward, and another clock cycle occurs, another one, another instruction cycle occurs, another one, and eventually until it reaches the period register value, the PR. Once it does, it rolls on over back to 0 and starts again with the counting. So if you put a prescaler and a postscaler, this means the time it takes it has to clock 4 times if you have to do a prescaler of 4 or postscaler even of 4. It has to clock 4 times before it even goes through this transition. So let's say you want a prescaler of 4 and a postscaler of 16. So it effectively has to go about 64 clocks. So it has to clock it 64 times before it even goes to the next. So as you can see, this pre and post scaler pretty much broadens the range we effectively have with each timer, because with each timer, we only have about 255 effective counts. Now this, if we take a 16 by 16, it times this by, 16 squared. And this broadens the range immensely. So that is effectively what the prescaler is for. Another important concept here. So what we're going to do, let's say we just want a post scaler of 1 and a prescaler of 1, and we want to turn the timer on at that moment. So we're going to make it all zeros, and then just set this little 1 to 1. So let's make it all zeros, and then we just check the third bit. Yes, bit 2. So this third bit to 1. So we're effectively using a 1 prescaler, a 1 postscaler, and just using 1. So we're using the instruction cycle as is. Next, we want to specify to the timer how long it should run before it actually, is done counting. And that is done using the period register. So for timer 2, we use PR2, timer 1, PR1, timer 3, PR3, etc. It's just every single timer has its own unique little period register. So at timer 2, let's say we want to run it for about X counts. Let's see, working, and then we move this value into our PR2. So let's say we want to run it for 180 times. Now, here's a little bit of a trick with the timer thing. Normally when you count, you expect 100, when you count up to 180, you expect 180 counts to have elapsed. But that is not the case with this counter, because if you go to this little example, if let's say you want to count to 3, and you want to, for example, you want to elapse 3 time periods, so it's 1, 2, 3, and then when it rolls over, it's 4. So effectively, there are 4 counts if you actually want to if you only make it 3. So if you want 3 counts, you need to make it stop at 2 and then have it roll over at 0. So whatever count you want, just make the period register 1 less than that. So if we want 180 counts, we're going to make it 179 to make it roll over only then. So now our counter is pretty much set up, and we can just, and when it does roll over, that is also an important thing. When it does roll over, you can effectively make it set some interrupt flag effectively. So you can go to the datasheet and you can see if it does set it to, let's see, the datasheet says it has its own little interrupt flag right here at the timer 2 interrupt flag there. Timer 2 to peer to match interrupt flag bit. So whenever a match occurs, whenever it does roll over, it set this bit to 1. Now it's up to you whether you really want it to interrupt the entire program every time it enters. Remember, with interrupt flag bits, it can set whatever flag bits it wants. But if the interrupt enable bits corresponding to this are not set, then it's not going to actually interrupt the program. So if you really want it to actually trigger an interrupt for that specific condition, you have to enable the interrupt. So if you want here, timer 2 IE, timer 2 to PR2 match in interrupt enable bit. But that is not as important in this case. If we just want a very basic counter, just a basic delay, so we're going to just be interested in this. So we're going to look at PR1, peripheral interrupt register, TMR2IF. So we're going to bit test file, period, peripheral interrupt register, and we're going to timer 2 interrupt flag, which is this. So we're going to effectively start looping the entire time. So it's going to skip the next instruction if that bit is set. If the interrupt enable bit, interrupt flag has been set, then it's not going to branch. So we're going to constantly branch to init. So we're going to see how this program actually does respond. So we can just quickly just put a little watch here to see what's happening with timer 2. And as you can see, it is currently looping through it. And it's counting, it's counting, it's counting. It's not at all stopping or anything. And then eventually it will reach this little value down there. See? And timer 2, it was just reset because it rolls over. Every time it rolls over, it resets by itself. So if you want to see the exact amount of timing it does actually do, so let's say we go back here and then we check. Let's see. Okay, so we're at the very start now. And from the moment we enable the interrupt, we can just see how long it takes. 188 microseconds. Now that's including this entire setup over here before the timer even starts. So that is a much more precise thing rather than, you know, this delay that we previously spoke about. And that is effectively if you want to do the timer by only checking the interrupt flag bit. And if you want to use it again, you obviously have to clear it. So if you want to clearing it, just to tell it it's not really, it has already occurred. We already serviced it. We got the information we want. So this allows it just to give us new information every single time. And yeah, that is about the timer 2. If you really want to make it an interrupt on its own, you can also set it as an interrupt. So that we follow the exact same process we did before. We enable the interrupt. We enable the interrupt on incon, the global interrupt 7. Let's set incon 6. And then we check where the interrupt enable bit for this little thing is. It is most likely in peripheral interrupt 1 or 2. Let's see. And it is in here, peripheral interrupt 1. So timer 1 IE. So we enable it, bit set of pi 1 2 IE. Wait, is this timer 2 IE? Timer 2 IE. So that is how you set up the interrupt if you're interested in that. So effectively, if it's not supposed to. So if you let's say move literal working, let's say 5, just to have some instruction, and we clear F the interrupt flag bits, and we re-enable the interrupt at 7, and we retfee. We return back where we were before the interrupt actually did occur. So we can effectively take this out, and we can just continuously cycle through this, and we should be able to get an interrupt here. So let's start here. And the program is running in parallel, it's doing its thing. And after a while, it was interrupted right at that stage. Just the moment it did interrupt, it threw it there. Now we're clearing the interrupt in there. We're going back. So you can see it's actually extremely useful to do it this way, because if you, for example, have a very important section of the program that needs to constantly be executed over and over again, but you only want to execute it for a limited amount of time before something else needs to happen, you set up a little interrupt, and it's with a timer, timer 2, for example, and then it finally does. When it finally does run out, it goes to the ISR, disables whatever process you wanted to disable, and does whatever you wanted to do, and then it can return again. So this allows for a much more parallel execution type of program. And that is basically timers.